Awesome. All right. Well, thanks everybody for joining today. We're going to do something a little bit different today. We're co-hosting a talk, myself and Rashid, one of our resident DevOps experts. So we're really excited today to talk about MLOps and cicd. So with that, let's dive in. I'll let Rashid introduce himself in a second, and we'll go from there. This is Tech Talk number 20, which is pretty exciting. Almost halfway through the year. We're here every Thursday, time change as of a few weeks ago. But today, what we're going to do, and then I'll hand it over to Rashid, is really talk about the traditional software developer development lifecycle and how CI/CD fits into that. You're going to hear from Rashid about best practices, common tooling, the benefits, a lot of really interesting materials, and at the end, we'll transition over to CI/CD's application in MLOps specifically. And we've built an integration to help facilitate and demonstrate that. So yeah, looking forward to that. I will pass it over to Rashid to take it over.
All right. Hey, guys. As Bradley mentioned, my name is Rashid Khan. I'm the head of DevOps at Modzy. I have about 25 years experience in the industry, and there's a little fun fact. I started my career in operations and competing with the top retail sites out there for highest performance and availability, and I beat Amazon at least twice while I ran shop, so I always like to gloat about that. Okay, so I wanted to start off by showing you a couple of slides that I found interesting. And here's a Gartner survey taken a few years ago of 367 IT and business leaders, of which 113 were using DevOps. They found that people and process issues were the primary concern among respondents. So people plus process equals culture. So I found that interesting. Next slide, please. Next, I wanted to show you this Google Trends screenshot on the term DevOps I took just yesterday. A value of 100 is a peak popularity for the term. You can see here that DevOps hit 100 just a couple of months ago. So one can argue that DevOps is as popular now as it's ever been. Next slide. So in the pre-Agile days, software development lifecycle was known as sequential development structure, aka waterfall. Comparing the waterfall methodology versus Agile, Agile follows an incremental approach, whereas waterfall is a sequential design process. In the 2000s, because of the advances and adaptation of technology, Agile principles and practices gained popularity in different software development organizations. The Agile mindset lowered the amount of time required to develop new application functionality, encouraging development teams to release early and often. However, certain catastrophic outcomes prevailed that deploying to production would still take weeks or months. By 2010, the introduction of cloud allowed for organizations and teams to quickly develop their applications and get a version deployed into production in a matter of hours or minutes. DevOps emerged to allow organizations to make this process routine and low risk. Today, organizations are adapting DevOps principles and practices to deploy their changes multiple times per day. Competitive advantage depends on fast time to market and innovation. And at the heart of DevOps is CI/CD. Next slide. So I always like to look at this slide. This is very shared. This is shared highly amongst the industry. And I wanted everyone to note how CI is on the left side and CD is on the right side of the loop. So why is CI/CD so important? Continuous integration, delivery, and deployment are software development practices born out of the DevOps movement. They make the process of building, testing, and releasing software more efficient and get working software into the hands of users more quickly than traditional methods. CI/CD facilitates an effective process for getting products to market faster than ever before, continuously delivering code into production and ensuring an ongoing flow of new features and bug fixes via the most efficient delivery method. Now let's move to the next slide to show the same process but with common tools used for each phase. Now let's break down the two. What is the difference between CI and CD? Continuous integration, or CI, is a practice that involves developers making small changes and checks to their code. Due to the scale of requirements and the number of steps involved, the process is automated to ensure that teams can build, test, and package their applications in a reliable and repeatable way. CI helps streamline code changes, thereby increasing time for developers to make changes and contribute to improved software. Continuous delivery, or CD, is the automated delivery of completed code to environments like testing and development. CD provides an automated and consistent way for code to be delivered to these environments. Now, continuous deployment is the next step of continuous delivery. Every change that passes automated test is automatically placed in production, resulting in many production deployments. Continuous deployment should be the goal of most companies that are not constrained by regulatory or other requirements. In short, CI is a set of practices performed by developers writing code, and CD is a set of practices performed after the code is completed. Now, releasing software can be painful and a time-consuming process. Continuous integration, delivery, and deployment have enabled many organizations to release on a more frequent basis without compromising on quality. With CI/CD, code changes are shepherded through an automated pipeline that handles the repetitive build, test, and deployment tasks and alerts you about any issues. Next slide, please. The primary goal of CI/CD pipeline is to deliver working software to users quickly and frequently. New features can be launched faster with deployment strategies giving you the option to experiment and collect feedback, which you can then incorporate into the next update. Being able to push changes out quickly and with confidence mean that you can respond to new trends and address pain points as they emerge. Having a shorter time to market doesn't just help you keep up with the competition. Rapid releases provide an opportunity for product managers and marketing professionals to engage more closely with the development process. Being able to test your innovations with users early and often means you can validate your approach before investing months or even years working on a feature that doesn't actually solve a problem for your users. With continuous integration, developers are encouraged to commit their code changes more often, at least once a day as a rule of thumb. Sharing code with the rest of the team regularly not only ensures everyone is building on the same foundation, but also results in faster code reviews and makes it easier to integrate changes. As we all know, practice makes perfect, and that goes for software releases as well. Adapting CI/CD is best done incrementally, starting with CI practices and building up your pipeline over time. Adding automation for builds, tests, environment creation, and deployments makes each step consistent and repeatable. And having broken it down, you can keep optimizing each stage to make your process more efficient. From being a significant event that occupies multiple teams for several days, with CI/CD releasing matures into a familiar, more predictable occurrence, thus resulting in a smoother path to production. Now, automation is a central part of any CI/CD pipeline, serving to make the release process repeatable and reliable. In the early stages of implementing CI, focus will be on automating the build process and on writing and running automated tests. Once you've established a solid CI foundation, the next stage is to automate deployment of your build to environments. Taking an infrastructure as code approach involves automating the creation of those environments. Rather than managing individual servers manually, their configuration is scripted and stored in version control so that new environments can be brought online quickly without the risk of inadvertent changes and inconsistencies. DevOps is much about building a collaborative culture as it is about new processes and tools. In order to get started with CI/CD, you need to start breaking down the barriers between teams and encouraging more communication. Breaking down silos between development and operations is just the start of a virtuous cycle. A CI/CD pipeline provides an opportunity for the many functions and specialists involved in building a product, from security experts to marketing teams, to get better visibility of the software development process and to collaborate with each other more. Many of the tools available to support an automated CI/CD pipeline also instrument the process, providing you with a whole host of metrics. Now, armed with this data, you can identify areas that might need attention so you can keep improving your pipeline. Slower builds may indicate a need to increase capacity, or an increase in mean fix time might be a sign of a process or cultural issue. Conversely, metrics can also provide reasons to celebrate, and so they should. Consistently extending your code's test coverage, reducing your defect rate, or increasing your release frequency all belong in the brag list and show signs of a great working culture. As we've seen, building a CI/CD pipeline eliminates waste and helps create a leaner, more efficient software development and release process. By using computers to perform repetitive tasks, an automated process also frees up individuals to be creative. Having the scope to be more creative and add value in what you do leads to an improved job satisfaction, which encourages people to contribute more, attracts more talent, and improves staff retention. In turn, that benefits your organization, your product, your users, and ultimately your bottom line. Next slide, please. It's not possible to overemphasize the need for security in a world where breaches and vulnerabilities continue to cause massive reputation and financial losses to business of all sizes and capabilities. Since the CI/CD system offers access to your code base and credentials to deploy to various various environments, it's often used as a prime target. Recall the infamous Uber breach where hackers gained access to AWS credentials that were embedded in the GitHub software repository, stealing personal information of 57 million users and 600,000 drivers. Uber then paid to cover it up, but that's a different story. It's certainly not uncommon for credentials to be stored in private repositories for automation purposes. Therefore, you should consider isolating your CI/CD systems, placing them in secure internal networks. VPNs, strong two-factor authentication, and identity and access management systems will help you enforce the principle of least privilege and restrict exposure to threats. In addition, you should also ensure that security is baked into the development process from start to finish. This is commonly known as DevSecOps. The goal for reducing branching is to spend more time on development and less time on version control. However, to make the most out of CI/CD, developers are expected to commit or merge changes from their local branches in at least once a day. This will force developers to deal with smaller, bite-sized bits of integration pain instead of massive integration pain and associated rework that happens when attempting to merge many branches into the main line just before a release. Keep the builds green. By building the solution and running a set of automated tests each time a change is committed, a CI/CD pipeline provides rapid feedback to developers about their change. The aim is to avoid building on bad foundations and keep the code in a constantly releasable state. Not only is it more efficient to address issues as soon as they arise, but it also makes it possible to roll out a fix quickly if something goes wrong. Build only once. A common misstep is to create a new build for each stage. Rebuilding the software for different environment risks inconsistencies being introduced and means that you cannot be confident that all your previous tests have passed. Instead, the same build artifact should be promoted through each stage of the CI/CD pipeline and ultimately released to production. The first layer of automated tests is normally unit tests, which you can use to provide broad coverage and alert you on obvious issues introduced by the latest change. After unit tests, you may have a layer of automated integration or component tests, which test interactions between different parts of your code. To get the most out of your testing systems, it's worth taking the time to clean up your pre-production environments between each deployment. When environments are kept running for a long time, it becomes harder to keep track of all the configuration changes and updates that have been applied to each one. Over time, environments diverge from the original setup and lead to drift. Consider using containers and an infrastructure as code approach to hosting environments and running tests. This makes it easy to spin up and tear down environments for each new deployment. Skipping CI/CD risks introducing avoidable issues, so make it the only way you deploy to production. By analyzing metrics collected by your CI/CD tool, you can identify potential issues and areas for improvement. And finally, building an effective CI/CD pipeline is as much about team and organizational culture as it is about process and tools that you use. So make it a team effort. With that, I'll turn it over to Bradley, who will discuss and demo CI/CD pipeline applied to MLOps.
Rashid, thanks so much. That was awesome. Excuse me. So that was great. We just learned a lot about CI/CD, its applications, best practices in the traditional software development lifecycle. And what I'd like to do now is transition over to talking about MLOps specifically. What we're looking at here on this slide, this chart, it lays out kind of the full end-to-end lifecycle of developing AI, with some common AI tooling categories below. We can simplify this a bit by breaking this entire process down into two main categories. One of which is training, so all tasks that go into the AI model training step and process, and then operations. And a lot of folks could argue that there are many steps along this pipeline that are ripe for CI/CD, but what we're going to walk through today is specific to MLOps. That is, we're going to work on delivering an AI model into production. So you can think of this AI model as the software, and we're going to leverage CI/CD to give data scientists the mechanisms and the tools to kind of automate that delivery through containers and through a deployment process. So before I dive into the actual demo, I wanted to set the stage a little bit. Let's say, for example, I am a data scientist, and my typical workspace and environment where I do my training experiments is, either at a remote desktop with some GPU access or locally on my laptop. And I have a GitHub repository where I do all of my experimentation. So let's say, for example, I've got a train.py file. It's a Python script that I'll use to train a scikit-learn logistic regression classification model. And I, typically will maybe like to save my model as a pickled weights file in a local directory. Now, if you were to tell me, Brad, go deliver this to a production application, and we'd love for you to implement all those best practices that Rashid just talked about, I would say, what are you talking about? I have no idea where to even start, right? And so this is the problem that we're solving. We're trying to bridge that gap between data science and DevOps worlds. And the way we're going to do that is via this integration we've built that leverages GitHub Actions and GitHub Workflows and ChassCML, which is an open source auto containerization tool, to take some Python code, some files, and deploy that all the way through to Modzy. Now, before I dive in, let me kick this off locally, and I will walk through the process with you guys live. So the idea and the objective of this, again, is to give data scientists an environment that is very similar to their normal workflow. And we don't want them to have to touch Docker. We don't want them to have to worry about containers, worry about the infrastructure provisioning, API endpoints, all these things that data scientists don't know. Our objective is to keep their environment exactly the same. And by simply making some changes to a JSON configuration file, we can trigger this entire process. So with that, let me pull up my browser. And bear with me for 1 second as I pull up some logs so we can monitor this in real time. Let's see. Not spun up yet. Okay, we'll get to this in a second. Okay. Rashid, can you confirm, can you see my browser right now?
Yes.
Okay, great. Thank you. All right, and I've got my logs now. Okay. So I'm also pulling up a terminal on the screen. So you should be able to see on the right side a terminal where we're seeing some logs run live. This is the chassis service. I'll talk about more in detail in a second. And on the left, we have this GitHub repository. So I'll give you a quick tour of this repository to start off with. First, I've got my simple train.py Python script. Again, this is what I just mentioned. And as a data scientist, this is where this is what I use to train my model and run some experiments. And I'm just going to happen to save my model, my trained model that I can load back for inference for downstream tasks in my weights directory. So here's what the weights directory looks like. Again, I'm just going to save it as my latest model, and I can put old and deprecated and archive pickle files in here. Now, as I mentioned, the one requirement that the data scientist has to follow to execute and trigger this CI/CD pipeline is editing this model info.json file. In this, we'll ask the user, the data scientist, to include 4 simple pieces of information that we need to deploy this model. The first is the name. Second is the version for deployment to Modzy. And the last 2 that are really important are the weights file. In other words, what model do we want you to deploy that chassis will leverage, and then a piece of sample data that we'll need during that process. So here's a quick overview. I'll get into the workflow itself in a second, but let's check on the progress of this. As we see here, the job is not completed. GitHub provides a very convenient and intuitive UI to follow the GitHub action. And so what we see here is a set of jobs that we've defined in a workflow file. So we'll go into this workflow file. And what we see on the left is again, these jobs that we've defined, but it's a little bit easier to follow kind of in the UI. Basically, the premise of this is the code that we're going to be executing in the CI/CD pipeline, we will set up our Python environment first using some Python-specific GitHub actions. We will install the required libraries that our Python model will need to run, and then we're invoking the chassis service. And that's what you see running on the right side of my screen. So chassis, as I mentioned, is an auto-containerization tool. In this case, there will be 2 components to the process. The first, Canico will take the model code that we've defined, and I'll show you that in a second, and build and push a container image out of that. As we can see, that is now executing, and it's pushing a sample model based on the name and version of the model that I gave. We can see it actually pushed. That's awesome. So if I were to go to Docker Hub and click on this repository, I can see this brand new model that I just built and deployed, and I haven't touched Docker one time. So this is pretty cool. Now, the second component after the Canico completes is what we call the Modzy uploader service. So if I then check out those logs, I can see that chassis is now interacting directly with the Modzy platform via some APIs, and it's deploying this container for us. So as I click into my Modzy instance now, go to model deployment, I see this GitHub workflow example model version 004 deploying as we speak. So I can go in here, pretty cool, and I can see kind of the different steps that Modzy requires, again, that we've automated entirely as it's happening in real time. But for now, we'll just continue to monitor the logs over here on the right and finish explaining this workflow. So again, the first couple steps that we can see both in the YAML file itself, where we've configured this CI/CD pipeline, and the UI, we set up our Python environment, and then we're defining some environment variables that our chassis code will need to access. And we do this using a feature called GitHub Secrets. Basically, as the repository owner, you can set secrets that are then accessible in CI/CD workflows that you're building. So what we do here is we'll cast those secrets to environment variables that are then leveraged and accessed in this chassis code. Now, this is the most important part of the entire CI/CD workflow that we've defined. This is where the magic happens. And what we're leveraging is chassis, as I mentioned. So what we have here is just some Python code where in order to execute a chassis job, we need some Docker Hub credentials in order to be able to build and push an image somewhere. In other words, right here. And we need some Modzy credentials to be able to deploy that model all the way through to Modzy. On the right, and if you're following along, we see that the model is loaded. So if we check out what that looks like in the UI, step 1 is complete. That's cool. That's great. And now it's verifying a status endpoint, one of a few checks that we make as we're deploying models in Modzy. Next, in the chassis code, we'll basically extract that JSON file, the configuration file that we expect data scientists to fill out. And from that, we'll get some useful pieces of information to execute the chassis code. The most important is the weights file path that we pass through in that config file, where we're telling chassis which specific model we'd like to deploy. And then we can define a process function. You can think of it as an inference function that will take some input data, use the model to make predictions, and then return the structured results to the user. And then lastly, we just use the chassis service to do the rest. Initialize our connection, and then publish that model. So you'll notice on the right that our model is now fully deployed. If I go back to Modzy, we see, I'll make this full screen now, that it's already published. That's great. Go back to my model details page. What's cool about this is, currently chassis will deploy it for you, but now as a user, my model is private only to me. I can go back in and edit this model. I can add documentation. I can add tags. And then once I feel like it's at a good spot to fully operationalize, I can change the visibility of this model and make it accessible to everybody in my organization. So we're running up on time here, and just wanted to highlight some conclusions. Number one, CI/CD is really useful in the traditional software development lifecycle. But as we've just seen, it can be really useful as well, leveraging that to make your MLOps processes more efficient. And so, now that I've created this one time, it took some work between the data scientist and the DevOps engineer to ensure that the pipeline works as expected. But now, I'm the primary model owner and maintainer. I will go back in and as I get more data, I'll retrain continuously. I'll make tweaks to the model to enhance performance. And because of this mechanism, I can simply go back to my GitHub repository, increment a new version every time I'd like to deploy a new version, and in a matter of minutes, get a brand new model in my production MLOps application in Modzy. So I'll stop sharing my screen. That concludes our talk today. I want to thank everybody for joining. Hope you learned something. I know I did when working with Rashid. DevOps is fun and really cool. So with that, we will be over in the general channel to take questions and chat for a little bit. But again, thank you for joining. Hope you enjoyed the talk.